Welcome back, folks. In today's class, I'll be talking about the chapter number 12. In chapter number 12, we'll be talking about the goodness of fit test. Okay, we're going to try and understand this topic with the help of an example. Let's say you are a sports scientist and you wanted to study how the swimmers perform when they run the race in the different lanes. So, in a swimming pool, just if you don't know, there are 8 lanes in a swimming pool. So 1, 2, 3, 4, 5, 6, 7, and then there is eighth one. Now, if I were to ask you what is the probability of swimmer running the race in the lane one or swimming the race in the lane one, what is the probability of he or she winning? You're gonna say 1/8. And same way for each and every lane, the probability is 1/8 because there are 8 lanes, so every lane has equal probability, so 1/8. Now uh, you uh, you are, because you are a sports scientist, so what you did is you went back and looked into the Olympics of 2024. In year 2024, all the races which were uh, which which happened during that Olympics, you collected the data for them, and you figured out that or the data told you that the swimmer who were in race in lane number 3 to lane number 6, they end up the people in those lanes end up winning the race more often than not. So now the question comes to your mind, that is running the race, is there any advantage of swimming the race when you are in lane 3, 4, 5, or 6, or it's just a mere coincidence? So to do that, you're going to write the hypothesis test and perform the test, and then you will try to figure out whether whatever that sample you collected from 2024, was that just a mere coincidence, or that actually is there some sort of an advantage to those people who end up running the race or swimming the race through the lane number 3 to 6. So whenever we are writing the hypothesis, it will always be same hypothesis for chapter number 12. So null hypothesis is always equal to expected or observed frequency. Observed is equal to expected frequency. And alternate hypothesis will always be observed not equal to expected. Observed not equal to expected. Now, how to figure out whether the question you are solving is from chapter number 12? So in chapter number 12 question, this kind of a wording will be used: goodness of fit test. Another wording might be given to you is, you will be given that multiple categories. So in this there are 8 lanes, so that kind of information will be given to you. So from there you'll be able to figure out if this is a question from chapter number 12. All right, let's look into this question. So a grocery store manager from the beginning of the chapter decides to test his theory that the distribution of the milk sales is uniformly distributed among the 4 types: whole, reduced fat, low fat, and fat free. He tracks the 2-liter milk containers sold of each type over the course of a week and records the result in the table below. So this is what he does. He's claiming that that all the 4 types are equally sold. Why he's claiming that? Because he want to make sure that his inventory is stocked properly. He's not buying, or he's not purchasing or shelving those products which not going to end up selling. So what he does is he conducts his experiment, and this is his observed frequency comes out to be. But then he says that, well, although his sample size is little off, but he says that it is observed observed frequency of the different bottles is equal to expected frequency for different milk bottles. An alternate hypothesis will be observed frequency is not equal to expected frequency. All right. Now, if I were to ask you what will be the expected frequency for these four milk types, so you will say total number of bottles sold is 490, so 1/4. So 25% for this one, 25% for this one, 25, because there are four categories. Each and everyone has equal opportunity. So I'll say each and everyone has 25% opportunity. So for that, if there are total 490 bottles sold, so 0.25 multiply by 490. Let me make a table down here, so in that way it will be easier for me to do the calculations. So let's see. So this is the milk type, and there are four milks, as we said, whole milk, and the second one is reduced fat, and the third one is low fat, and the fourth one is free fat, and then total number of bottles sold are 490, and whole fat was 125, and then reduced fat was 130. These were bottles sold for reduced fat, and 119, and then 116. One more time, these are observed value. Observed means that actually happened on the ground. Okay, this was his sample. In his sample, this is what he observed. And expected means what was ideals under the ideal scenario, what would have been the outcome. So this would have been 490 divided by 4, which is 122.5. Same way this will also be 122.5, because they all have equal opportunity. 122.5, 122.5. So under the ideal circumstances, 122.5 bottles of this, 122.5 bottle of this, and 122.5 bottle of the other two would have been sold. So now what we're gonna do is we just gonna run our test. So to run the test, it is always a single tail test. It is like this. Okay, single tail, and the single tail is always a right tail also. And this is the chi-square critical value. So then you do the test. How you find out the test value? You use the function FO minus FE squared divided by FE. This is the formula you're going to use to figure out what is the chi-square test value, and then where this test value lies, depending upon that, you will reject or accept the null hypothesis. Now, how are you going to find the critical value for this question? Critical value, you will look into the table. So you are given there are four different types of milk, and uniformly distributed over a 5% level of significance. 5% level of significance. Alpha value is 0.05. Now look into the last page of your formula booklet and look into the chi-square distribution. This one on top, this diagram is also there. So you will see a right tail diagram, chi-square distribution. In the chi-square distribution, as I said, alpha value is 0.05, and then degree of freedom. So degree of freedom is n minus 1. N minus 1 will be, or k minus 1 shall I say in this case, because there are categories, k minus 1. So degree of freedom is, like in this number of categories are 4, because there are 4 types of milk, 1, 2, 3, 4. So that will be 4 minus 1, which is equal to 3, and that's what you figured out. So correspond to degree of freedom 3 and alpha value of 0.05. You will look for the value on the table. It will come out to be 7.81 on the chi-square distribution table. Don't look into the z table or t table, look into the chi-square table. All right, so this value comes out to be, chi-square is 7.81. And now once you figure out this value, let me just also quickly recheck this value. Yeah, this is on the last page, correspond to the 3, it is 7.81. Now that is chi-square critical. Now you will do the test. So how you gonna do the test? You will first of all FO minus FE. You will write down the value here, FO minus FE, FO minus FE, and then you square it. So this will be 125 minus 122.5 square. That will give you 2.5 square, and which is 6 point something. Okay, we'll do that later on. So then the next step is 130 minus 122.5, and that is 130 minus 122.5, which is 7.5 square, and 122.5, oops, 119 minus 122.5, which is minus 3.5 square, and then 116 minus 122.5 minus 6.5 square, and then the final, yeah, these are pretty much the four ones. So 2.5 times 2.5, which is 6.25, and then I will add one more step to this formula, because the formula here, if I see, is divided by FE. So whatever the value, you square it here and then divide it by FE also. So divided by FE is 122.5. This is FE. This is FE. This was FO. So this divided by 122.5, and then 7.5 square times 7.5 divided by 122.5, 0.459, and then the next one is 3.5 times 3.5 divided by 122.5. This comes out to be 0.1, and the next is 6.5 times 6.5 divided by 122.5, 0.345. Now I will add all these values. So 0.345 plus zero point 0.1 plus 0.459 plus, first one I didn't do it, so 6.25 divided by 122.5, which if I add now all these four values, it comes up with to be 0.955. Now that is the chi-square test value I got, chi-square test, which is 0.955. And I'll see where does it lie. So this value is 7.81. So obviously the value will lie somewhere here. So thus it means I cannot reject the null hypothesis. If the value is on the right hand side of the critical value, you will reject the null hypothesis. Here, reject null hypothesis. Here you can't reject null hypothesis. All right. So if you cannot reject the null hypothesis, and now we're going to compile the answer. So observed frequency is equal to expected frequency. And that's what grocery manager also said. So test the grocery store manager's claim that the distribution of the milk sale among the four different types of milk is uniformly distributed at 5% level of significance. He is actually in this question claiming that observed is equal to expected. So I will keep his claim. He's not claiming something else. He's not, it's not always that alternate hypothesis is always the claim. Null hypothesis can be the claim. This is a perfect example of that the null hypothesis is claimed. So we accept his claim, okay, because we couldn't reject the null hypothesis, and null hypothesis was his claim. So hopefully you were able to understand this question. Now, with this, I'm going to take one more question. That is this one, chi-square goodness of fit test when you are given the expected frequency in percentage. Now, what is going on in this question? If we see this question carefully, We are given the local t-shirt company buys the t-shirt and customize them with the original images for their customers. The manager orders the t-shirt based on the proportion of each size she thinks she will be able to sell. She would like to compare her actual sales size to the sales of she is expecting for each size. Okay, to gather the sample data, she counts the number of t-shirts sold in each size over the course of a week, perform the goodness of fit test, 10% level of significance to figure out whether the proportion of t-shirts sold in each size is consistent with the proportion of the t-shirt order in each size. Okay, that's what we wanted to find out. Again, null hypothesis will be equal to observed frequency is equal to expected frequency, and alternate hypothesis will be what? Observed frequency is not equal to expected frequency. That's how you're going to write the alternate hypothesis. Again, this is always the right tail chi-square distribution. How did I figure out the chi-square distribution? You're given multiple categories. You are given multiple categories are given to you, and on top of that, you are also given in the question. Well, it's not written here. If you gonna read through the question completely, I think I forgot to mention it, the proportion value also. Yeah, so I need to complete this question. So we need to, let me quickly see. Well, is it given here or not? Let's see, 10% actually given. So my apologies. So it is given. Perform a goodness of fit test. Goodness of fit test at 10% level of significance. So that is given to you. So alpha value is 0.1, and how many categories are there? 1, 2, 3, 4, 5. 5 categories. So degree of freedom will be equal to 5 minus 1, which is equal to 4. So correspond to 4 degree of freedom, and alpha value 0.1. You're going to try and find out the value. So if I look into the periodic table, not the periodic table, into the booklet, formula booklet, the value will come out to be for 4 and for 0.1 of alpha, this value comes out to be 7.78 if I'm not mistaken. So 7.78, this is the value you're gonna get for chi-square critical. That is critical value 7.78. Now, well, let me write it. Chi-square critical equal to 7.78. Now you're gonna do the test, chi-square test. So which are the different t-shirt sizes? XS, the second one is S, third one is medium, fourth one is large, fifth one is XL. So XL. So these are the 5 categories, and the number of t-shirts sold, that is observed value, 18, 20, 33, 37, 42. And then expected is given to you. So specific frequency is given to you for expected 10%. 10% of what? 10% of total. Total is 150, because if you add all these values, these are 150. So 10% of 150 comes out to be 15. And then the next is 8%. 8% of 150, that will be 12. And then 25% of 150, 37.5. Next one is 45, and the final one is 40.5. So these are the expected values. So F, now I just need to do this, x square equal to FO minus FE, square it, divided by FE, and take the sum of all these values. Oops, I didn't the space here. Sum of all this, chi-square test, that's what it is. So you're gonna write down here FO FO minus FE, then square it. So this will become 3 square. This will be 8 square. This will be 33 minus 37. This will be minus 4.5 square, and this will be 45. So 8 square, and 42 minus 40.5, so 1.5 square. That's how you're gonna get the values. So when you're gonna square it, then you're gonna get, this will be 9. Then down here you need to, well, I don't need this one. So this will be 9 divided by FE, which is 3 square is 9, which is 15. So 8 square is 64 divided by 12. And same way 4.5 square, I don't know the value of 4.5 square. So that will come out to be 4.5 times 4.5 divided by FE 37.5, which is 0.54. And previous one is 64 divided by 12, which comes out to be, this value comes out to be, let me change the color, 5.33. 9 divided by 15, which comes out to be 0.6. And 64 divided by here it is 37, not 37, 45 shall I use, 45. So 64 divided by 45, which is 1.42, and 1.5 times 1.5 divided by 40.5, which is 0.055. Okay, so this number plus 1.42 plus 0.54 plus 5.33 plus 0.6, that comes out to be approximately 7.95. So this value, where does it lie on the table? This is 7, critical value 7.78. So 7.95 will be somewhere on this side. So you reject the null hypothesis, reject HO. So if you reject the null hypothesis, you will accept the alternate hypothesis. So then what you're gonna claim as final answer? So we performed the goodness of fit test at 10% level of significance to figure out that the proportion of t-shirts sold in each size is not consistent with the proportion of t-shirt ordered in each size. So not consistent. That will be your final answer. So hopefully you were able to understand how to solve these questions. All right, so I will see you with another video. Till then, goodbye.